Hi, I'm Bob. Welcome back to my solutions to Econometric Analysis, a tutorial on exercises and application for the textbook Econometric Analysis, the 8th edition by Professor William Greene. In addition to providing my answers to the problems step by step, I will verify the results in Stata with real-life examples or simulated data. Today, we will continue solving the exercises at the end of Chapter 3 of Least Squares Regression. Let's find the answer to Exercise 5. It's about adding an observation to the dataset. Suppose we already have n observations. Now, an additional observation, xs and ys, becomes available. We need to show the expression for the new least squares estimator with the additional observation. We can write down the original model. I write it in matrix form with elements to help understand the question. The original OLS estimator is Bn. It's based on n observations. When another observation is available, the new model can be expressed in matrix form as follows. The new OLS estimator is based on all n plus 1 observations. The xns is a matrix, and the yns is a column vector. The xs is a column vector and the ys is a scalar. Now, we focus on the new OLS estimator. The part of xns times yns is a column vector, and we can write it in terms of xn, yn, xs, and ys. For the part of the inverse of xns prime times xns, we resort to the formula A66 in the appendices of the textbook. The new OLS estimator has 4 terms. The first term is the original OLS estimator, Bn. We then combine the second and the fourth terms. Finally, we reach the answer. The new estimator is the O1 plus a term. xs prime times Bn is the fit value, ys hat, that is computed using the original OLS estimator Bn and the additional observation of x. In case 1, ys equals ys hat. It implies that the original OLS estimator correctly predicts the new outcome ys. That is, the new observation on y can be perfectly predicted using the information already in hand. The additional observation does not bring any new information to the regression. If this is the case, Bns equals Bn. The OLS estimate does not change with the additional observation. In case 2, when ys does not equal the fit value computed using the OLS estimator, the new OLS estimator BNS will not be the same as the old OLS estimator BN because the additional observation contains new information that cannot be predicted by the old observations. We can verify this result in Stata using simulated data. We generate pseudo-random numbers in Stata and use the data generating process to create variables with particular properties. We first set a seed to any number we like so that we can get the same sequence of pseudo-random numbers each time we run the program. Then we decide the number of observations. It is 100 in our example. Next, we generate the error term epsilon, the explanatory variable x1, and the outcome variable y. Y is a function of x1 and epsilon. We set the true coefficient of x1. As we run the regression, we have the OLS estimate for the coefficient. It is close to the true parameter we set. Now we add an observation to the end of the dataset, the number 101 observation. We set a value for the explanatory variable x1. Suppose the observation for y is the fit value from the regression using the 100 observations. Or equivalently, the new observation can be perfectly predicted using the information already in hand. In this case, when we regress the model, including the new observation, the OLS estimate does not change. By contrast, if the new observation on y cannot be predicted by the original model, say it is 1000, then the OLS estimate for the coefficient will change a lot. Let's go to exercise 6. It is about how to handle the observation with missing values. It proposes 3 strategies. The first is to fill the missing variable with 0 and add an indicator variable to the model. The second is to delete that observation. The third method is to replace the missing values with the sample means. We will show that these 3 strategies lead to the same OLS estimates. We should be able to distinguish between observations and variables. We write the model in matrix form. Suppose we have a last observation for y, but x has a missing value. In the first strategy, we have an additional variable as an indicator for the last observation with missing values. The indicator is a column vector containing 1 for the last observation and 0 for all other observations. Then we partition the model. The idea is that the explanatory variables are divided into 2 sets, x and s. According to Frisch-Wahl-Levels theorem, the partial regression coefficient estimate Bn can be expressed using the residual maker matrix Ms. When x is pre-multiplied by Ms, it results in the residuals in the regression of x on s. It is x without the last observation. To see it clearly, we write out the definition of the residual maker matrix and use matrix algebra. It shows that x pre-multiplied by Ms results in x dropping the last observation. Similarly, y pre-multiplied by Ms leads to y dropping the last observation. Therefore, the OLS estimator is the same as deleting the observation with missing values. Next, we show that it is also equivalent to replacing the missing value with the sample mean. If we replace the missing value of x with the sample mean of the observations already in hand, the new OLS estimator will be the same if the additional observation does not bring any new information to the regression. It is the conclusion of exercise 5. Using old sample means for the additional observation does not bring any new information. So the OLS estimate will be the same as without the additional observation. Next, let me show you these 3 strategies in Stata. We use simulated data. After we set the seed, we decide the sample size. I use 100 observations. The last one is the observation with missing value in x. In the first strategy, the last value of x is 0, and an indicator variable s is created. We regress y on x and s using all 100 observations. The OLS estimate is 2.10892. In the second strategy, only the first 99 observations are used in regression. We drop the last observation with missing value in x. The OLS estimate is also 2.10892. The standard error and t-statistic are also identical. Since these 2 models have different sample size, 100 versus 99, the R-squared should be different. The third method is to replace the missing value with the sample mean from the 99 observations. The OLS estimate does not change. Thank you so much for doing the exercises with me. See you soon on the following exercises. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.